here's my question. Here's my question. For what value of x? Or you can say a, does limit x approaching a, f, exist? Or we can actually, better example, not exist. Not exist. I just realized that infinite values sort of did exist. All right. See if you can do it yourselves. Give it about 10 to 30 seconds. You want to think carefully. Then what's going on again? Under what conditions will the limit not exist? That's a release question. It came on a multiple choice. Let's say Mr. Lozano. For which value of a, x, a is an x value, does the limit not exist? Okay. Does anybody disagree? Mr. Crawford? Just negative 1/3. Why not negative 4? There's a whole of negative 4, and limits exist at wholes. A very profound question. So the correct answer is x equals negative 1/3 only. X equals negative 1/3. Because that's a vertical asymptote, right? Make a note that x equals negative 4. That's a wrong answer. Limits exist at wholes.
If it were like the problem on the smartboard?
The smartboard question. How about the smartboard question? Smartboard question, negative 4 still works because, look at the board please, the negative 4 will cancel this, x plus 4 will cancel this x plus 4, will you still have an x plus 4 on the bottom?
Yeah.
That will still be a vertical asymptote.
Right.
But here, when I cancel the top, I have an x plus 4 on top. There's no problem there. But we still have a hole. We still have a hole. So, yes, go on.
So if the question was still, the limit does exist?
Oh, no. Here's the problem. It says, I realize, okay, I was being a Fino. Fino is very, very careful and particular about language. He would actually argue, limit exists, but now I'm addressing Mr. Nava's point. Nava says, then will you write negative 4? You'll write negative 4 and negative 5 and negative 6 and negative 1 and negative 2 because they're infinite values. So the limit exists. The limit exists at all other values, but including negative 4 also. That's why I changed it. Okay, exists. But actually infinite values is limiting. I can plug in any other value. Okay, but on the other hand, if the question had said, write on part B, for what value A does the, so write on part B, for what value A is f not continuous. Exactly same problem, but for what value is f not continuous? Then the answer would be negative 4 and negative 1/3. Because negative 4, we have a whole, negative 1/3, we have a vertical. Discontinuity is a whole. The funny thing is, this question arose in a calculus AB, and I said, man, I need to discuss this idea because it's an important concept. Okay. Let's discuss question number 1. So write down, find the horizontal asymptote for that. We did this a long time ago, but I want to go over this. Write down number 2. Find the horizontal asymptote for that one.
Does not exist.
Not so fast, not so fast.
Solution.
Okay. Stay with me, please. How do we always find horizontal asymptotes? Okay, the x approaches infinity. Y approaches. We've got e to the negative 2x times cos x. So let's think about what's going on. What's e to the power of negative infinity? 0. So that's 0. Okay, now slow down. We've discussed this before. What's cos of infinity? Don't be in a rush. Why does it not exist? It fluctuates between negative 1 and positive 1. So the larger point is this guy goes from negative 1 to positive 1. Therefore, final answer? 0. 0, 0 times any number between negative 1 does not exist, but is a finite quantity. Okay, and then when x approaches negative infinity, y approaches, we still have the same. Will this guy still be from negative 1 to positive 1? Some finite value, but really does not exist. But what's negative of negative infinity? So final answer, does not exist, or infinity. No? So the correct answer to the problem, the horizontal asymptote is 0, because the other one does not exist. So you need to slow down and think through them. These are not guess questions.
Wait, I'm lost on the negative 1 to positive 1.
All we are saying, Mr. Bourbon, is it is a finite quantity between negative 1 and positive 1, but the limit does not exist, as in there's no constant value the graph approaches, correct? The whole concept of limit is, what is
It
that?
does not exist?
Huh?
It does not exist?
Yeah, it's almost like this. Write down number 3, please. Write down number 3. We did this in pre-calculus, because Baylor would have done it, and so did I. Write down limit n approaching infinity, negative 1 to the power of n. Okay?
Oh, yeah.
Why is the answer does not exist?
Because it was a negative, positive 1, negative 1.
Thank you. Depending on what n is, even or odd, is that negative 1 or positive 1? But it's not a finite single quantity, therefore it does not exist.
Yeah, that confused me even more than what we're doing.
No. Can you see if n is an even number? That's positive 1, negative 1 to 1.
Oh, okay, now that makes sense.
Yeah, it's like plus or minus 1.
Yeah.
But it's not a single value. The whole concept of limit is, what is the single value y approaches?
So then how did, for the first one, you get 0?
Once again, e to the power of negative infinity is 0. 0 times any number between negative 1 and positive 1 is still going to be 0.
You're so good.
Okay, let's do part B. I'm making a part B. Write this down. Now what's the answer? 0. Because that guy is a finite quantity, either plus 1, minus 1, but divided by infinity. You need to think through the problems.
So the numerator does not exist.
Yeah,
It is a finite
but
value,
when I
we
say,
don't
yeah,
know
it's a
what it
finite
is.
quantity, does not exist, there's no one single value,
Okay.
but we are dividing by an infinitely large value, that was 0.
Got it.
Okay. I want to discuss a couple of questions from yesterday's homework. Just a quick thing, all right? We discussed most of them in class, so you should be fine. Have a look at 3A. I'm just going to spend about 5 minutes. I'm racing to them. Be on your best intellectual behavior. Okay. Shh. It says at pi over 6. Is the object getting closer or farther away from the origin? Should I basically look at S of that and B of that? Ms. Nava, pay attention, please. So see if they have same signs, opposite signs, and make a conclusion. B says, is the object speeding up or slowing down? Should we compare V and A? See if the same signs, opposite signs. And draw a conclusion. All right. Have a look at number 5. We have discussed questions like this before. It says, what is the position and acceleration of the object when it's first at rest? So what does it mean? It's at rest.
0.
The velocity should be 0. Find the velocity function, set it equal to 0. Find t, and plug in the position and acceleration. All right. Make sure you're doing your homework. All right. These, I hope all these came back to you very, very quickly. All right.
Those are the hardest questions I've ever seen in my life.
Have a look at number 10, please. It says compare. There is one question like this in your semester, and I'm letting you know. Number 10. Compare f dash of 1 and f double dash of 1. So this is the f dash graph. What's f dash of 1? Obviously.
1 point.
Positive, yeah, 1 point monkey. But what do we know about f double dash? Negative, it's concave down. One slopes are increasing. So you just say which of them is higher, all right? Not complicated. There is a question like that. That was straightforward. Then these are, okay, I just want to go set it up, see if you're fine. We'll kind of go over every problem. You have like 3 or 4 of these on your final, all right? So just write down day 72 homework. Just draw a line. Write down day 72 homework. Okay, you have about 4 questions like this. We'll only set up and discuss, like, okay, did I do this correctly? Did I think through the problem correctly? It says at equal to 7 is the amount of ore increasing or decreasing. We will assume to begin with that you have the A function is the amount. That's the amount of ore at time t. So it's A dash, basically E of t minus L of t. Is that clear? Because we've done this concept for 2 chapters. It's very, very important. So what am I just finding for 12? A dash of 7. Which is E of 7 minus L of 7. Is that basically F3 of 7? Correct. And then it says at an increasing rate or decreasing rate. So what do I find for that one? A double dash of 7, correct? So that'll be E dash of 7 minus L dash of 7, which is basically F3 dash of 7. You basically see with positive, or let's say here, positive. 13. It says calculate and interpret E of 3 minus L of 3. So what is E of 3 minus L of 3? A dash of 3 basically. And that tells you the rate at which the amount, the rate at which the amount is increasing or decreasing. It just tells you at 3 is the amount increasing or decreasing, correct? At 3 is the amount, which is the derivative of the amount. The rate of change of amount. At 3 is the amount increasing or decreasing. The units will be just tons per hour or whatever. 14. It says calculate the maximum and minimum amount. How do we do that problem? Critical points, endpoint, and then what do we do with those? Or rather, find A of. So we'll find A of 0. A of, was it 8? A of 8. Using the net change corollary, right? A of 0 is given. Oh, that's what you're saying. Okay. A of 8 is A of 0 plus integral. See if this comes back. 0 to A dash of t. And then A dash we know, E of t minus R of t. And we'll do that for monkeys as a critical point. And there's only one critical point, correct?
Yeah.
Questions?
This is net change corollary.
Corollary, yeah.
How do you say it?
Corollary or corollary? I don't know the American pronunciation. Anyway. So that's 14. Okay. 15 is straightforward. It just says state the interval over which the amount is decreasing. Graph the derivative function, which is given, and just see where it's below the axis. Yeah. Straightforward. Number 16. Calculate and interpret E dash of 5. Okay, I'll do that for you because some kids have trouble with the language. Okay, we're doing E dash of 5 minus L dash of 5. Okay, so we're doing 16, which is E dash of 5 minus L dash of 5. We'll call it monkey. Okay, we'll call it monkey. What about my units do?
Tons per day squared.
Tons per day square, or I think hours. Tons per hour square. Is that clear? Because am I not basically finding a double dash of 5? Okay. I'm going to call out the interpretation, write it down please. Indicates that at t equal to 5. So I called this out even in my AV class because the top kids are fine. The bottom kids are like, huh? Is it obvious it's the rate that is increasing or decreasing? If that's greater than 0, let's assume it's, I think it was less than 0, right? If I remember the problem. I think it was less than 0. I'm just going to make it up.
Yeah,
It was,
like
right?
1.5.
Indicates that the rate of change, again, indicates that it's the derivative function, the rate of change of the amount of ore at the factory. At equal to 5 indicates that at equal to 5. The rate of change. Mr. Bourbon, this is the one you slacked off on, write down the interpretation. How we interpret.
I'm not idea.
Yeah, then you should be paying more attention, not less.
It's really early in the morning also.
I don't give a flying. It would be funny if I say, like, I don't give a flying, and then say fuck. That would be funny. And it's like, I'm stopping, I pause because out of politeness and courtesy and saying flying, okay. He was almost there, but he didn't. And then saying flying fuck, okay? So in my IM3 class yesterday, there was a kid who was whispering, and he said something like, he said, we goof off a lot. Sorry, but in IM3 we make lots of jokes. So this kid, he sits here. He's called Mr. Dan. All right, he's a junior. He's called Mr. Dan, and he always wants to be the first out the door when the bell rings. It's the speed at 6. So he gets really annoyed when I'm wasting time because then worst case I may keep them after class for 30 seconds, right? he gets really annoyed because he wants to be the first racing through the campus. I don't know why. But anyway, so he whispers under his breath, but I have a very good hearing. He says, oh, for fuck's sake, all right? And I said, Mr. Dan, what did you just say? Is this what you said? Okay, this is what I write on the board. Is this what you said? We don't use this kind of language in class. For and sake? What does your mother say? You use this kind of language at home? Your mother approves of these words? Anyway.
First gag of the year.
Alright, so I'm calling this out, write it down, indicates that the rate of change, or the rate, we say rate of change of amount, okay, indicates the rate of change of the amount of ore at the factory is decreasing at the rate, and it's okay because it's the rate that's increasing. Indicates the rate is decreasing at the rate of monkey tons per hour squared. Okay, indicates that the rate of change of the amount of ore, I mean at T equals 5, is decreasing at the rate of, you can just say decreasing at monkey tons per hour squared. All right. Have a look at 17, please. Again, I'm spending precious class time going over every problem. It says, find the average rate of change for the amount of ore entering the factory. So, how do we do average rate of change? M set. So what's careful? So 17. Is this basically M set for the amount function?
Yeah.
Is that basically A of
I don't
2?
think it's E, it's entry.
Oh, entering. Thank you. E of 2.
Minus E of 6.
Oh, no. Oh, okay. Is that the amount entering, right? Not the actual entering function. Is the amount. Right?
Sure.
No, look at the problem. Is the rate of change of the amount entering. We don't know the amount entering. Am I making sense? Does everybody understand why the problem is different from probably what you thought it was? It's the average rate of change of the amount entering, not the rate entering. Okay, just play along. Is that amount entering minus amount entering at 6 over 2 minus 6? Is everybody okay here? I'm showing you how to set up the problem correctly. Here's what you should do next step. Is that 1 over 2 minus 6 integral, I'm going to use net change. 2 to 6, just E of t then. That I can do. I know the entering function. How many of you understand what I just did? Okay. So if you did this is incorrect. I'm letting you know, if you did this is incorrect. I'm almost certain many of you did this. Raise your hand if you did this.
I did that.
That is incorrect. But please understand why that is wrong. Please understand why that is wrong. I did not say find the average rate of change of the rate at which, that's the rate function. Do you understand that? That is the rate function, not the original function. We need the average rate of the amount entering. Okay, that's the amount entering. I don't know exactly how much it enters. I can find it. Okay. Here's another way to do it, but it's more complicated. Can I find E of 2 as like 2 to 6 E of t?
Yeah.
How many of you understand what I'm doing here? Correct? That's the total amount entering from 2 to 6. Or 0 to 6 rather. And that's 0 to 2, 0 to 6 approximately. So that's tedious. Net change is net change is easy. Okay, now look at 18 please. Look at 18. It says find the average rate, this is easier. Find the average rate at which coal is leaving the factory. Why is 18 different from 17?
Amount, and then that's average rate of change.
Yeah, guys, have a look at the board, please. This is average rate of change, this is M set. This is just average. You see, that's average. And then rate at which. So let's set up 18, please. Is that just the average formula? And then 1 over 5 minus 1, 1 to 5, the rate at which I'm leaving. The average rate, again, average rate. This is the rate function, so we can do that. If you're not doing your homework, you lose out on a lot. And Mr. Bolwani, you have no excuse with Manrique is sending solutions. So you should study the solution and say, oh, okay, that's what is going on.
Yeah.
Okay, but if you screwed around for almost a month that chapter, there's no excuse. You have to bring yourself back. So anyway, okay, now we're doing a new lesson. Okay, we're discussing chapter 5 now. All right. which is integration, okay? Elementary integration. So we're going to race through this. Just copy down the function. Looks like a weird function. That comes in a multiple choice. It's a calculator problem. We won't do it. We'll talk about it. It says let h of x be 0 to x negative t squared plus ln t plus 1 plus 1.5 dt. Question number 1. Again, it's a calculator problem, multiple choice, no work required, but we'll discuss what's going on. It says over negative 2 to 2, for what values of x will h have a relative extrema? So you know the problem. Let me just talk about concepts. How do we know if a function has a relative max or relative min? Careful, a relative max or relative min. What do we look for? This is louder. Sign change for the derivative of the function. Everybody will get that. If you sign change, if you have relative max or min, f dash should change from positive to negative or negative to positive. Yes? So is that h dash then? Ooh! Would that make it the derivative and integral? Is that basically FTC2? Does it come back to you? FTC2 is basically, and then evaluate upper limit minus lower limit. So let's have a look. So we're doing question, we'll do 1 and 2 together. And then part 2 says h dash have an inflection point. Actually, that was the title. So it will be h have an inflection point. Anyway. So we're doing 1 and 2 together. So we'll do relative extrema. Basically, h dash of x changes signs. And as in the h dash, basically integral. Oh, see if this comes back. Negative x squared plus ln x plus 1 plus 1.5 times one, and the derivative at the top. That's FTC2. Okay, that's FTC2. You plug in the top times its derivative minus the bottom guy minus x minus 0 squared plus ln of 1 plus 1.5 times 0. Will that collapse? Am I now on my calculator? See if I'm making perfect sense. Will I just plug that in and see where the sign change happens? Very elementary problem. Did everybody understand the concept? So just make a note to yourself. Just graph that sign change. All right. Yeah, it's a calculator problem. And see where there's a sign change. Okay, question number 2. Question number 2 says, for what value will this, what's your name now? Reducing. Be good last. Can you hit backspace? Delete the h. There you go, h dash. Thank you. So have a look. It says h have an inflection point. Ignore that. What is the concept of inflection point again? H double dash changes signs. All right. So make a note to yourselves. So basically h double dash of x changes signs. Is this guy already, oh, make a note here, is that already h dash of x? Yeah, that's h dash of x. So shall I do h double dash? Which is negative 2x plus 1 over x plus 1, and that's it? Should I just look for a sign change here? Can I graph that? Just make a note, sign change. Okay, your calculator handle it. Okay? That's how elementary the problem is.
See where it changes signs and
That's it. That's it. Graph that function, see where it changes signs. That's it. Now, in that interval, negative 2.
You don't have to take off the end, right?
Nothing. You have to do zero math. This is a calculator problem. The calculator is all right. Have a look at number 3, please. Have a look at number 3. It says, okay, this is complicated. This is again a multiple choice problem in the AP exam. Only because you have to keep track of the origin and what the limits are. So stay with me. You don't need to write anything. I'll tell you what's going on. It says water is entering a tank at the rate of 1 over blah blah blah. What are they giving you there? Say R of t. Yeah. Or V dash of t or something like that. All right. So write down number 3. So V dash of t, which is 1 over radical 5t plus 1. Everybody okay with that? Volume, water is entering. So volume function. That's liters per hour. It is the number of hours after 7 a.m. I'm going to keep track of that. I bolded it for you on the AP, of course it was just written normally. keep track of what the origin is. So the origin is 7 a.m., all right, keep track of it. If there are 50 liters at 9 a.m., so careful. So what are they really giving you there?
2.
V of 2.
V of 2.
Not V dash, V of 2. V of 2 equals 50. How much water is left at 10 a.m.? So what are they asking for? V of 3? Everybody okay there? Because 7 a.m. is the origin. V of 3. Tell me what to write on the right hand side. V of 2 plus V dash of 2. V dash of 3. Yeah. Everybody okay there? And V of 2 is given to be 50 plus 2 to 3, 1 over radical 5t plus 1. Show every step. Show every step. Okay, let's integrate that. Let's do the shortcut. Who remembers the integral? Careful, careful. Who remembers the integral of 1 over radical monkey? 2 radical monkey. So that's 50 plus 2 radical 5t plus 1 over 5. Don't forget that. It's a linear function. It's a linear function. So I write it cleverly over 5 on the side, yeah?
So this is definite. There's no plus C.
Yeah, it's a definite integral. There's no plus C. Lower limit 2, upper limit 3. We can do this quickly. 50 plus 2/5, big brackets. 5 times 3 plus 1. So what is that real? Minus 5 times 2. Oh, bloody hell. 10 radical 11. And that's okay. Just leave it like that. No, it's okay. I mean, it was a multiple choice question and that was the choice. Then leave it alone. Okay. Okay, write down number 4, please. Same kind of problem, but one thing has changed. Okay, read number 4. I'm going to race through this. Be on your best behavior. 4 says water is leaking from a tank at the rate of 5t plus 1. Okay, so V dash of t. You're like R of t, which is V dash of t equals radical 5t plus 1. Where t is measured at t equals 0 corresponds to 12 a.m. Keep in mind the origin now is 12 a.m. If there are 100 liters initially, because this is V of 0, right? How much water is left in the tank at 4 p.m.? We need V of 4. Oh, 12 a.m. We need V of 16 then, correct?
I don't know how time
That would explain your tardiness.
What time is it?
12 a.m. is 0. It was a gag based on what you said. All right, everybody okay there? 12 a.m. is 0. We need 4 p.m. So that's 16 hours. What am I writing? Careful. Hint, look at the blue information also. What am I writing? V of 0 minus integral 0 to 16 V dash of t. Show the word. This is Lenore would. This Manrique would.
And it's minus because it's
Leaking.
decreasing.
Yeah, exactly. That's the decreasing function, or leaking function. So that's 100 minus integral 0 to 16 radical 5t plus 1 dt. Okay, who can tell me how to integrate that one? Thank you. So 5t plus 1 to the power of 3 over 2 times or divided by? Okay, I'm going to write 5 like this. Everybody okay there? It's a linear expression to divide by the derivative of the linear. 0 to 16. 100 minus, is that 2 over 15? I'm pulling it out. Big brackets. 16 times 5? 80. Okay, I did this quickly. 80 plus 1? Square root? Cubic? It's 729. I did it quickly. 729. Minus. Is that just 1? Okay. Final answer 100 minus 215 times 728. Whatever that is. That's now arithmetic. It's my job to show you how to do it. Have a look at number 5, please. Copy down number 5. Guys, let me say this emphatically. I've said this before, I'll say it again. These last 10 days, you will not get a single question out of the questions I'm doing in class or homework. You will not get a single question out of them. So if you can make sure, it's a most thorough review. So if you can make sure that you know how to do every single problem, you'll be fine. Don't be cocky. It's one thing saying, looking and saying, yeah, I know how to do it. Very different from, I do it and saying, oh my God, I'm making so many mistakes in doing it. Is that clear? So you need to be doing your homework and you need to be knowing that I know how to do homework. Rather than, yeah, I vaguely remember how to do this. Okay, it says f double dash of x is that. Write a possible expression for f of x. So what do we just do? Take the integral twice. Is that clear? So let's first find f dash of x. Yeah, I'm just integrating once. So what am I writing for the first expression? Very smart. Pull out the negative 5/4. I was testing that concept. Can you pull out fractions? And then x squared over 2. That's okay. It looks weird, but that's fine. And then plus 1/2. Okay, now careful. I'll give you a hint. I'll give you a hint. Guys, that's a linear expression. Keep that in mind. That's a linear expression. So tell me how to write. E to the power of x over 3 times 3. Does everybody understand why we're multiplying by 3 and not dividing by 3? Because if that was 3x, will I divide by the derivative? But if I divide by 1/3, will I become times 3 then? Are you able to follow the logic? Just slow down, okay? What am I doing for sine 2x? Negative cos 2x over 2 and 1/2. Okay. I'm going to rewrite. Please, rewriting is your friend. It'll be faster. Negative 5/8 x squared plus 3 over 2 e to the power of x over 3 minus 1/2 cos 2x. Slow down. Because all of you think, oh, I get it totally when he does it in class. But I'm not saying this to shame you, but your test scores reveal that you're making lots and lots of mistakes. Let's do f for it. Oh, plus c. Yeah. It's an indefinite integral. And now f of x, I'm just integrating both sides again. Negative 5/8 x cubed over 3 plus 3/2 ex over 3 times 3 again minus 1 over 4 sine 2x plus cx. Guys, here's how we do this. C1x, because that's one constant, plus C2. You can call it C1 because we have two constants. They're different constants. You cannot, guys, if you write this on the AP exam, you will get marked down. It is not the same constant.
Right.
Or there's no reason to be the same constant.
It could be.
It could be.
What if I put like D?
Yeah, the D is perfectly fine. Okay. I'm going to rewrite it. Negative 5/24 x cubed plus 9/2 ex over 3. Rewriting is your friend. You get so many more points if you just rewrote. C1x plus C or Cx plus D. That is acceptable. So that was the only simple integration problem. Okay. I'm going to change the problem. Guys, make it just, okay, fine, we keep it initially. I may change it somewhere along if it's very tedious. Okay, so write down what h of x is. It says is a limit from x to 0. Okay, where h of x is defined below. F of x is defined below. Okay, this graph there. We're doing number 6. It says calculate the absolute maximum of h of x. Okay, so h of x is defined as x to 0, sorry, x to 0 f. How do we always find absolute maximum? Evaluate the function at the critical points and the endpoints. The endpoints are negative 4 and positive 3. X equals negative 4, x equals positive 3. For critical points, should I set h dash equal to 0? Yes? Is that the derivative of an integral? So should I do f of 0 times minus f of x times, which is really negative f of x. And that should be 0, right? So is it obvious that f of x should then be 0? If negative f of x equals 0, then f of x should be 0. When is that true? Negative 3 and 1.5? You're going to assume 1.5. Everybody okay there? What do we do with these guys? Evaluate the integral. Okay, so show work. I'll only do a couple of them. So h of negative 4. Show the work. Is that negative 4 to 0? F, So let's do this very quickly. Is that a quarter circle with radius 1? So is that basically pi over 4? Yes? Pi r squared divided by 4. I made a mistake. What's the mistake I made? Negative, because that's below the axis. Careful. All right, and the other quarter circle has a radius of 3 squared, pi over 4, plus, okay, pi r squared divided by 4, pi 3 squared, pi over 4. So final answer, 2 pi? Yes? Should we do h of 3? That's integral. 3 to 0, f dt. I'm doing it slowly and carefully. You have to be attentive. 3 to 0. Guys, if I do 3 to 0, I'm seeing, so look at the board. I'm going to calculate 3 to 0. What did the answer be? 0, because the areas is cancelled. I mean, technically, I'm seeing, so look at the board. Technically, that guy is positive, other guy is negative.
Because they're different sizes.
No, they aren't.
Well, you don't
1.5?
know. It could be like 1.51.
Okay, 0.
Oh,
All right. And then h of negative 3, show the work. That's negative 3 to 0, h, f, show the work. We already calculated that, right? Which is 9 pi over 4. And then finally, h of 1.5. Do that yourselves. What is the area from 1.5? Smarter kids, you can think of 1.5 as 3 over 2. For those who don't get it, what is the shape of that figure? Triangle. What's the area of a triangle? Half. What's your base? 3 over 2 or 1.5? And what's your height? 3. Is that the final answer?
No, it's negative.
Negative. Is that clear? Final answer, negative 9 volts. We write down a conclusion. Write it down. Absolute max of 2 pi? Yes? Absolute max of 2 pi at?
So what would it be
9 pi over 4 minus pi over 4. The first one we did. Not the second one, yeah, the first one we did. At negative 3, yes, an absolute min of,
No, but is it 9 pi over 4 greater than 2 pi? Wouldn't that be that?
I think you just said. You just corrected it.
You did?
yeah, oh sorry, you're right, 9 pi over 4, not 2 pi. Yeah, 9 pi over 4 at negative 3. I did the negative 3 correct, but I chose the wrong value. And an absolute min of negative 9 over 4. Is that the lowest? At negative 3. Is that clear? At, which one was that? 1.5, correct? It says, over what interval is the function increasing or decreasing? We went over it in question number 1. How do we always do a function is increasing or decreasing? General. How do we do if a function is increasing or decreasing? H dash. Ooh, look above. But H dash is really? No, look at what you wrote.
It's a negative.
Negative f of x.
Yeah.
Okay? So for increasing interval, I'm showing the work. Should negative f of x be greater than 0? Therefore, f of x should really be less than 0. I hope you understand the logic. Now can we read on the graph?
Or is it not?
Which is negative 4 to negative 3, and then 1.5 to 3. Mr. Borbore and Mr. Nava, you have a fair point. The AP question clearly said 1.5 was the x-intercept. The actual AP question in the wording said 1.5 is the x-intercept. Otherwise too, for those of you like ultra smart, how can I determine the x-intercept of that line? Nobody speaks. How do I know that a 1.5 is the x-intercept? I don't give you. How can I actually determine it is the x-intercept? Who can tell me?
So find the formula.
Yeah, can we find the equation of that line? And then find its x-intercept. It's not like can't be done. All right, will decreasing interval be exactly the opposite? F of x should be greater than 0.
Yeah.
So that goes from, oh, careful. This is important because some of you lost points because some of you break. Now have a look. Everybody, look at the board. F of x greater than 0. I'm going to tell you the wrong answer. Negative 3 to 0, 0 to 1.5. Why is that incorrect? Why are you breaking that? What is the reason for your breaking? At 0, are you above the axis? There's no reason to break. But some of you are not thinking carefully enough when to break, when not to break. So the correct answer is -3 to 1.5. All right? The question then says concave up or concave down? Number 8. Stay with me. Okay, how do we do concave up or concave down? Or say concave up? No, double dash greater than 0. So is that h double dash should be greater than 0? Hey, wait a second, from an earlier problem, do we not know h dash of x equals negative f of x?
Yeah.
So let's just take the derivative of both sides. So h double dash of x should be negative f dash of x. If that is greater than 0, what must be true? F dash of x should be less than 0. Do you understand the logic? Break it down. Don't skip steps. Think through the problem. Okay, now look at the graph. The slope of this function should be negative. Where does that happen? 0 to 3. I hope you're following the logic. And then concave down. Is it obvious then by complement f dash of x should be greater than 0? Then you can skip the step. And that happens for, oh, careful. I'll tell you the wrong answer. -4 to 0. Nobody speaks. Why is that incorrect? If you wrote -4 to 0, you will lose points in the grading rubric. Why is that incorrect? Where? At -3. Thank you. At -3, the slope is undefined. You need to slow down, think harder. So -4 to -3. That's the concept of you need to know when to break. In the earlier problem, we wanted to be above the axis. At 0, you are above the axis. There's no problem there. Why are we breaking? Okay. Okay, question number 9. Question number 9 says, find the equation of the tangent line at x equals -3. So h of x. What are the two things we need to write the equation? You have one question like this in your final. I'm letting you know. What are the two things we need to write the equation line? Point and a slope. As far as point goes, write a number 9. Is that just h of -3? Relax, we already found it. Isn't h of x? Show the work. Is that -3 to 0, f? Was that 9 pi over 4? Again, now I'm telling you the difference between, say, Leno and Manrique and the rest of you. What's this? They would write this step. Therefore, -3, comma 9 pi. So they're keeping track. Okay, that's the x value, that's the y value. What do we do for the slope? Careful, I'm showing you. First find h dash of x. Ooh, we actually know h dash of x. What is h dash of x? Negative f of x. Then plug in. See, again, small difference between some lower level kids and upper level kids. Upper level kids actually show that step. Now, h dash of -3 equals negative f of 3. -3. Was it 0 actually? Yeah? So it's just 0. Now I'm doing a board but a silly gap. Negative of 0. It's a sort of silly thing you say. Yeah. Okay. So, which very bright fellow will tell me what is the equation of the line? Nobody speaks. We need the equation of the line. Hint, we just found the slope to be 0. Why negative? It's positive.
Oh, yeah.
So check your final answer. Is it a horizontal line? For those of you who don't get it. The slope is 0. It's a horizontal line, therefore y equals 9 pi. You had a question like this actually on your chapter test. Okay, I hope that was a very thorough review. Okay, we'll do 11. This was question number 1 on the chapter test, and I was alarmed. The majority of the class shut down. Like most of you, I'm talking about out of 41 students I have, I'm thinking probably about 35 got this wrong. Okay? How many of you remember this vaguely? Like question number 1, you just shut down. Like, what the hell happened in this problem? Okay, copy that problem down, please. I say f of x equals this, and then write the wording, because otherwise you will not know what you did. The question said, find the slope of f of x. Okay, capital F of x. The question said, find the slope of f of x. All right? So f of x is given to be -1 to x sine t cos t. Of course, the question of the test is slightly more complicated. Put down, say, radical x. Right? It was slightly like that. So what's this? It said slope. What's another word for slope? Are we finding the derivative of an integral? FTC2. So write down f dash of x equals sine radical x cos radical x times 1 over 2 radical x minus sine -1 cos -1 times 0. Mr. Crawford, even though you can see ahead and think 0, it's smart to still write that down. So final answer, sine radical x cos radical x over 2 radicals. That's it. It usually comes in multiple choice. It doesn't come on FRQs. That's it. And the reason kids got here's what kids are doing on this question. They were really trying to say, how do we integrate that? There's not required integrals. It's a find the slope of that. They were FTC2. There are actually kids trying to integrate that function. And it was a very weird question. Okay, I remember it was something like this. Look at the board, cos ex. There are kids, how cute is it? That's why I'm just chuckling. Like, it was super cute. Kids said, oh, cos ex is sine ex divided by the derivative. No, that's not a linear function. None of that crap works. How many vaguely remember doing that? You basically took the derivative of that and divide by the derivative. Okay. Anyway, so that's not how it's done. The question said find the slope, which means take the derivative of integral FTC2. Okay. So we'll do part B. It says find the instantaneous rate of change of f dash of x. So what should we find first? F dash of x. So we will do that now. That problem. So f dash of x, we'll just do that problem. Is nothing but just sine x cos x, correct? Everybody okay there? F dash of x is just sine x cos x. We're doing that problem. Okay? But look at part B. I need the instantaneous rate of change of that function. So what do I have to do next step?
Why is it just sine x cos x?
No, we got rid of radical x. I just made this a simple x problem. So should I find the second derivative? What do I do? How do I do that? Product rule. Thank you. So sine x times negative sine x plus cos x times cos x. So negative sine squared x plus cos squared x. And they gave us a value and we can plug it in. We can actually do this in our heads. What's sine of pi over 4? So f double dash of pi over 4. So negative 1/2 plus equals okay, write down number 11 please. So once again, read the wording. It says slope or derivative, you're just applying FTC2. Okay, read number 11 please. It says suppose f of x equals that, take that down. I may not do the entire problem, but we'll set it up. 1 to x, 2 over 1 plus t squared. It says find the average rate of change of f of x. So what is the question asking you to find? MSEC of capital F of x. So should I basically find f of 1 over radical 3 minus f of radical 3 over 1 over radical 3 minus radical 3? Yes? It's the average rate of change of capital F of x. So should I just find each of these separately? Okay, it can't be done quickly, all right? Oh my God, I am brilliant. I'm sometimes amazed at my own brilliance. It's like I can't look at the mirror anymore because I'm amazed at my own brilliance. It's like seriously gleaming. The English word is scintillating. Okay? The other English word is coruscating. Okay? The sparkle is so strong. What's this? I'm going to blow your minds. What's this? This is how I taught this last year. Can you do 1 to 1 over radical 3? Is that, what integral is that? tan inverse. Can we do tan inverse, blah, blah, blah? Yeah? And can we do the same thing for that? And then do this? What's this? I'm going to blow my mind. I'm blowing my own mind. What's this? 1 over radical 3 minus radical 3 integral from radical 3 to 1 over radical 3 capital F dash of x. Net change. I can do the net change. And what's the integral of f dash? Is I just say plug it in upper limit minus lower limit? That's just 2 over. Okay, just simple f of x. Correct? F of 1 over radical 3 minus f of radical 3. Okay, I'm just doing the integral of a derivative over 1 over radical 3 minus 1. This can be done very, very quickly, so you don't have to do crazy stuff. You just plug that up. Okay, that's just a regular function. Integral. No, what? Am I right?
No, you're not.
Actually, I think I'm not.
Yep, your own brilliance has failed.
Yeah, probably.
You be careful.
F dash. Oh no! I'm okay. No.
Nope,
I'm
you're-
okay because capital F dash. No, I'm not.
Yes, you are.
No, because capital F dash is just F, correct? Yes.
Is it? I don't know.
Oh yeah. Sorry. So it becomes 1 over radical 3. No, we can simplify it a little bit. Okay, so that's radical 3 to 1 over radical 3, 2 over 1 plus 2. So we can do the definite integral directly. So 2 definite integrals. That's all I'm saying.
It's all wrong.
Okay. Stop. Before I move on, look at the board and convince yourself it works. Okay. Okay. See if this works. That becomes integral capital F dash. Capital F dash. We're taking the integral. The derivative. Well, I just get this guy. So I just take integral. So I have to do one problem instead of 2 problems. So we get slightly shorter. We'll skip 12 and 14 is on your test, guys. 14 is on your test. I'm letting you know that. But it's a simple problem. It is a very simple problem. It actually mirrors the problem we did earlier this morning when we were reviewing the homework. It says g of x equals 0 to x f dt. Okay? Okay, and the question says compare g of 3-point monkey, g dash of 3-point monkey, and g double dash of 3-point monkey for the full nav and board bane. When I say 3-point monkey, it is this monkey. Not that monkey, not that monkey, not that monkey. Oh, no, sorry, not that monkey.
Are you sure? I thought that was Ken.
Okay. So I'm just going to work the problem, see if it's obvious. Is g of 3-point monkey basically 0 to 3-point monkey f dt? And what do we know about it? Just look at the graph. That value will be
It'll be positive.
positive. So we know that's a positive number. Right?
So that's all we have to compare?
Yeah, you just have to compare. One of them will be positive, one will be negative, one will be 0.
Alright.
Let's do g dash of 3-point monkey. What do I find first? G dash of x.
Yeah.
Okay. What's g dash of x?
F of x.
F of x, ftc2. Don't forget, ftc2 is the derivative of an integral. Is that just f of x times 1 minus f of 0 times 0? This is f of x. Therefore, show that step. F g dash of 3-point monkey is
So
f of 3-point monkey, which is
0.
0. Okay. I'm showing the steps, you can see what's going on. And then finally, we need g double dash of 3-point monkey. So what should I find first? G double dash of x, which is f dash of x. Now I'll plug in g double dash of 3-point monkey. F dash of 3-point monkey, which we know to be a negative number. Yeah, look at the board, please. The slope of the tangent line there is negative. We know less than 0. And the question says in ascending order. Oh, sorry, it says, the question on the final will say in ascending order, which is clearly the smallest guy. G double dash of 3-point monkey. Then G dash of 3-point monkey. And then finally, the regular. So I'm showing you how to work the problem. Show work. I say clearly in black. I say show some work for the explanation.
Alright.
No, almost done. Number 15, please. Read number 15 with me. This may be the last problem.
It may be. Oh, yes.
It depends on the time. Copy number 15. Let's see who, if anybody remembers, you have one question. I'm letting you know you have one question like this absolute value function. Who remembers how we find the integral of an absolute value function? Or rather, better still, what do we do first? Anybody? I'll give you a hint. Basically, all areas are positive. Therefore, what should we find first step? Nobody remembers.
Do we plug in a test value? Don't we break it?
Yeah, so we break it up where? Where does the break happen? Thank you. Louder, Arroyo. At the roots, we find the x-intercepts. So, since most of you have forgotten, write down that's -2 to 1. Absolute value x squared plus x.
Ramaswamy.
Yes.
Lenal said the roots, so
She wasn't loud enough then.
yeah, but she said it.
Okay. So make a note to yourselves, find the x-intercepts first. Then we break up the interval. So that's x squared plus x equal to 0, x plus 1 equal to 0. What are your roots?
0 and negative.
0 and -1. So we'll break up the interval, but keep track of the lower limit and the upper limit, yeah? So we go from -2 to -1, x squared plus x dx. I'm going to say, write something profound, look at it and say, oh yeah. But we need to make every area positive. Absolute value there. Does that come back to you guys?
Yeah.
Plus, what's your second interval? -1 to 0, x squared plus x. Second absolute value close. And then finally, from 0 to 1, x squared plus x. Absolute value. Let's actually do that very quickly. These are small numbers. What's the integral of x squared plus x? X cubed over 3 plus x squared over 2. Lower limit -2, upper limit -1. Absolute value. Don't forget. Show every step. The final question is kind of tedious. You have to work it out. Same way x cubed over 3 plus x squared over 2. -1 to 0. And then finally x cubed over 3 plus x squared over 2. -1 to 0. Yeah, and then you just plug it in, upper limit, lower limit, very carefully. Guys, don't forget to use parentheses, yes? Use parentheses when you're subtracting the definite interval. So that we have pretty much fairly thoroughly covered this chapter. Make sure you do your homework. Do not skip any question. Check your solution in Ms. Lenore, Ms. Manrique, Mr. Pino. They are all reliable students. If you have questions, come during lunch. But if you bomb the final, blame yourself. Like, okay, he told me everything from the homework will be on the final. But I chose not to work. I chose to be lackadaisical.
When we bomb the final, when you do all the homework.
No, that will not happen. That just cannot happen. That will not happen. Perfect example is there are slackers in the other class last year. Guys, hear this before you leave. Like Lacey Cooney, Marie Vaughan, and Abdul Bari. But they did the 10 days and all 3 of them did much better than some of the smart kids like Kobe Huen, who did their work during the year but slacked on the last 10 days. Kobe Huen got almost an F on the final. But these kids got B's on the final. Okay, so for your own sakes, do your homework.